This learning module is going to count as extra credit, and it is an extension that combines both 1.6 composition of functions and 1.7 inverse functions. So as a quick review, composition of functions typically is shown as the following notation, and what this means is that the function of g will be substituted for x inside of the function of f. And this can be also written as f of g of x. And then, of course, inverse functions. This is a quick way to show this, but here I have the standard equation y equals mx plus b. And when you're trying to find the inverse of any equation, you simply switch y for x and x for y, giving us x equals my plus b. And of course, to finish this off, you're going to want to solve for y. So I wrote that down here, interchange x and y, and then solve for y. So on this slide, you've been given two functions, g of x and f of x. And here you're being asked to take the inverse of both of those functions, then find the composition of f of g, and then substitute in -3 to get your final numerical answer. So clearly we have a lot going on here. And we're going to start by finding the inverse of each function. So I'll keep them in the same order that they're presented. First, I'll start with g of x, which is equal to the square root of 4x minus 32. We're going to replace the g of x with a y to make this much more simpler. And then, of course, I'm going to start this off by switching out my x's for y's. So I have x equals the square root of 4y minus 32. And now the goal is to get y by itself. So we basically need to reverse everything that's happening on this side. We got to get rid of this 32. We got to get rid of the square root. We got to get rid of this 4. We just got to make sure we're following the proper order according to our algebra rules, okay? So I'm going to start by getting rid of the square root. So we're going to square both sides of the equation. So now I have x squared is equal to 4y minus 32. And then, of course, we're going to add 32 to both sides, giving us x squared plus 32 is equal to 4y. And now my final thing I'm going to do here is divide by 4. So I'm going to end up with y is equal to x squared plus 32 divided by 4. And of course, I have to replace the original notation. So g of x inverse, that's why I raised it to -1, is equal to, and I'm going to write 1/4 in the front as a fraction, is equal to x squared plus 32. So all I did here was, instead of putting a 4 in the denominator, I made it into a fraction. I put it out front, and then I placed everything else inside of a parentheses. So we have our first inverse equation. Now let's go ahead and find our second inverse equation. So now I have f of x is equal to x minus 6 over x plus 2. And this is going to turn into y equals x minus 6 over x plus 2. Again, that's to make our lives easier. Then we're simply going to switch out our x's and our y's. So x is equal to y minus 6 over y plus 2. And now, again, the goal is always the same. I need to get these y's as one single y all by itself on one side of the equation, okay? So again, you want to follow your algebra rules here. Think about PEMDAS. Think about what you do when you're trying to reverse things. So I'm going to start by getting y plus 2 out of the denominator, and then I'm just going to flow with the problem. So we multiply both sides by y plus 2. Now I'm going to end up with x times y plus 2 is equal to y minus 6. Now I'm going to distribute x here. And I'm going to end up with yx plus 2x is equal to y minus 6. Now I'm going to move any term with a y, so this term and this term to the same side, and any term without a y, so this term and this term to the same side. So I'm going to get plus 6 minus yx minus yx, and I end up with 2x plus 6 is equal to y minus yx. Here, I see that both of these terms share a y, so I should immediately be thinking, let me factor out that y. So we factor out a y, I end up with 1 minus x, and we have 2x plus 6 on this side. So now to finish off this equation, I'm going to divide both sides by 1 minus x to get this y all by itself. So I'm going to zoom out just a little bit to give me more writing space. But I'm going to end up with f of x raised to the negative 1, because it's the inverse, is equal to 2x plus 6 divided by 1 minus x. So now I have both of my equations, g of x and f of x, as their inverse. So on the previous slide, we found the inverse of f of x, we found the inverse of g of x. Now we can move on to the composition. So if you remember from the first slide, whenever you're doing a composition, the second function always gets substituted for x into the first function. So let's go ahead and write this out. So I have f of g of x to the negative 1 to the negative 1. What this is going to look like is wherever I have an x in my first function, I'm going to replace that with g of x. So 1 minus, I'm going to put that in a different color just so y'all see what's happening. So 1/4 x squared plus 32, and then 1/4 x squared plus 32. We're going to start here by cleaning up the numerator and cleaning up the denominator. And then once we're done cleaning up the equation, we'll plug in -3. I'm going to start by distributing the 1/4 on the numerator and the denominator to my x squared plus 32. Distributing 1/4 here, distributing 1/4 here. The same thing's happening down here and down here. So I'm going to end up with 2 parentheses 1/4 x squared plus 32 over 4, close parentheses, plus 6. And then in my denominator, I'm going to have 1 minus 1/4 x squared plus 32 over 4. Don't forget to replace your parentheses around the bottom equation. And the reason why that's important is because there is now a negative you need to distribute down here, and there is a number 2 that you need to distribute up here. So we're going to go ahead and take care of that. So I'm going to end up with 2 over 4x squared plus 64 over 4 plus 6, and then 1 minus 1/4 x squared minus 32 over 4. So moving forward, you're going to want to simplify this fraction, combine these terms, simplify this fraction, same thing in the denominator, simplify this fraction, combine it with the 1. 2/4 becomes 1/2 x squared. Our 64 over 4 becomes 16. and then plus 6, and all of that is again divided by, and I'm going to move the negative 1/4 to the front, negative 1/4 x squared minus 8 plus that 1. So we end up with 1/2 x squared plus 22 all over negative 1/4 x squared minus 7. So now that I have my composed function with both inverse equations, I'm going to finish off this problem by plugging in negative 3 to x. So I'm going to scoot over to give myself a little bit more room. So I'm going to say is equal to 1/2 parentheses negative 3 squared plus 22, and all of that is going to be divided by negative 1/4, and again parentheses negative 3 squared minus 7. So on top, negative 3 squared is 9. Multiply that by 1/2. I get 9 over 2 plus 22 over 1, because I want to make that a fraction. And then my denominator is going to turn into 9 over 4 negative, and again, subtracting a whole number, but I want to turn that into a fraction. So remember, adding or subtracting fractions, find a common denominator. I'm going to multiply the top by 2. I'm going to multiply the bottom by 4. So now I end up with 9 over 2 plus 44 over 2, and that's all going to be over negative 9 over 4 minus 28 over 4. And this is going to give us 9 plus 44, which is 53 over 2, all over negative 9 minus 28, which gives you negative 37 over 4. Now remember, whenever you end up with a 4-story fraction, you're always going to follow keep, change, flip. You keep the numerator, 53 over 2. You change from division to multiplication, and you flip your denominator, negative 37 over 4, to 4 over negative 37. So we end up with 53 over 2 times 4 over negative 37. Now again, the 2 and the 4 are going to simplify, so you end up with 53 times 2 over negative 37, and you end up with 106 over negative 37. And this fraction is in its most simplified form, so this is my final answer. That was a lot of steps. So as you can see, to solve this problem, first you got to find the inverse of both equations separately. Then you've got to compose both functions by putting them side of each other. And then you've got to finish off by plugging in negative 3 for x. Now go get yourself some extra credit.